Today's lesson is on graphing using slope-intercept form. This lesson will focus more on one particular topic, and it's important to get it because you will spend a lot of time using it in mathematics, geometry, algebra 2, pre-calculus, calculus, business, science. It's very common. So, first things first, how do we graph an equation y equals mx plus b? Well, what do we call the m? That's called the slope. M equals slope. And as we've discussed before, while the m for slope, nobody really knows. A lot of guesses about that, but nobody's sure. B is the y-intercept. We'll show you how all this works when you're graphing. And we call this form slope-intercept form. So how does it work? Well, it's not too difficult. Graph y equals 1/2 x plus 2. So we'll make a graph, and we'll make it over here. We'll only need a few tick marks. Over here, we'll write the slope. M equals 1/2. And B equals 2. If we remember, this is the change in y over the change in x. So we start here. We go up 2 on the y-axis, and I'll label the axes just this time. So up 2, and that's where it hits. And then 1/2, change in y is a positive 1, so we go up 1. And we go over 2. Only need 2 points to create a line. If you felt like it, you could go up 1 more and over 2 more. And then connect 3 points. Whatever works for you. Usually we'll just connect the 1. That's it. That's how to graph y equals mx plus b. Let's try it again over here. So slope is 2. Now 2 doesn't really help me, so I always put it over 1. Because then I remember that it's the change in y over the change in x, and then go from there. And then don't forget to watch out for your negative. B equals -3. So in this case, we go down 3 to start. 1, 2, 3. And the change in y is 2. 1, 2. Change in x is 1. There we go. Remember, positive slope. This is a positive slope. This is a positive slope. Goes up to the right. Up to the right. The greater the number, 2, 7, 22, 156, the steeper the line will be. The more fractional the number, 1/2, 1/3, 2/5, 1/7, 2 100ths, the flatter the line will be. So you can always check your work briefly when you're done. Looks like we did those correctly. A couple more examples. I'm going to draw my graphs at the same time to save a little time here. So over here we have m equals -3, and again I'm going to put it over 1. Notice we have a negative now, and b equals 2. So go up to 2, 1, 2. Change in y is -3, 1, 2, 3. Don't forget to count here. 1, 2, 3. Over positive 1, so right there. And we connect the dots. Notice a negative slope goes down to the right. Notice it's 3, -3 in this case, so it's a steeper line. Over here we have to do a little math first, which is why we learned that earlier. 2y plus 6x equals -2. Move the 6x over. 2y equals -6x minus 2. Divide everything by 2. Y equals -3. I'm going to put it over 1 for now. X minus 1. We just did this kind of problem, so it's only a little bit different. It should be the exact same line, except start at 1 instead of up at +2. 1, 2, 3 down, 1 over. Notice we go down 3 and 1 over. We could actually write a slope of m equals 3 over -1. Those are equivalent. So we could also go up 1, 2, 3, and over -1 to the left. And it's still going to work. There's our line. So what do we notice about these two lines up above? They start at different spots on the y-axis. This starts at 2, and over here on the right it starts at -1. We call those lines parallel lines. What makes them parallel? Well, that's actually quite easy. They have the same slope. They're not the same line because they hit at different spots on the y-axis, but they are parallel because they have the same slope. In both cases, m equals -3. Those are parallel lines. We'll be doing more with those as we go along, and also when we go to solve two systems of equations, that becomes something of interest. Now, a little bit of practice, since this is such an important concept. Identify the slope and y-intercept of each equation. Notice we did not ask you to graph. This one's easy. M equals 5, b equals -3. This one we have to manipulate. Move the 3x over. Divide everything by -3. Notice how nice everything's working out. It won't always. Y equals 1x plus -4. M equals 1. B equals -4. X plus 4y equals 6. Now we get some stuff that looks a little bit more challenging and something we'd expect to see in a real problem. Divide by 4, divide by 4, divide by 4. Y equals -1/4 x plus 3 over 2. Some slightly ugly numbers, but that's fine. M equals -1/4. B equals 3 over 2. Over here we've got a big mess, which is fine. Plus 6x plus 2 plus 6x plus 2. 7y equals 11x plus 6 divided by 7 divided by 7 divided by 7. Y equals 11 over 7x plus 6 over 7. M equals 11 over 7. So if you were going to graph it, you'd go 11 up and 7 to the right. B equals 6 over 7. And that's it. Now we actually got to graph them. They're already set up for us. So let's make our coordinate systems. And some people say it's a lot easier to use graph paper. I would agree, except we don't always have graph paper handy. And these are, even though they're quick and dirty graphs, that's how we describe them, meaning that they're not perfectly precise, they're still pretty good. They usually give us what we need, which is a quick idea of what we're dealing with. A slope that's positive, a slope that's negative, a steep line, a somewhat flat line, things like that. M equals 2/3, B equals -1. While I'm here, M equals -3, B equals 4. Change colors for graphing. Go down -1, up 2, 1, 2, over 3, 1, 2, 3. Connect the dots. Slightly flatter line because it's between 0 and 1. The slope is between 0 and 1. B value of 4, 1, 2, 3, 4. -3 over 1 if it makes you feel better. 1, 2, 3. Negative slope down to the right. -3 is a fairly steep slope. And that's it. Good luck. Make sure you know how to do this. It takes lots of practice.